Hey everyone, and welcome to the second episode of Ask Google Cloud. This is a show where we solve humanity's greatest mysteries, like did the chicken or the egg come first? Oh wait, hold on. No, I'm actually being told that our poultry experts aren't able to make it today, so we are just gonna stick with cloud topics. I'm Stephanie Wong, a Google Cloud Developer Advocate, and today I'm joined by Dale Markowitz, an applied AI engineer here at Google, and Sarah Robinson, a developer advocate focused on AI and ML. And I'm both huge fans of you both. So Dale, Sarah, how are you doing? Thank you so much for being here.
Thanks for having us, Steph. I feel like I've been seeing a lot of you lately.
I'm omnipresent.
Doing good over here.
Well, I'm excited to have you both. Today, we'll be answering questions submitted by you, our amazing Google Cloud YouTube audience. We're always looking out for your questions about Google Cloud products, so be sure to leave any questions you may have in the comments of our videos using the hashtag AskGoogleCloud. And if you have any other questions that come up as you're watching today, then please go ahead and type them in the live chat. I think it's probably somewhere over here, and we'll do our best to try to get to all of them. We'll be hosting Ask Google Cloud segments throughout the year, so be sure to subscribe to the channel to get notified every time a new episode goes out. So, with that said, let's go ahead and get started with today's topic, which is AI and machine learning. Our first question comes from Verdict, who asks, how do you get started with AI ML with a non-technical background? So, Dale, let's go ahead and throw this question to you first.
Man, I get this question all the time, and my answer really changes depending on what you're going for, what your background is. As a developer, which is a technical background, I always like to tell people you should go at machine learning by trying to find a project that you actually wanted to do anyway that uses ML, and then just use the simplest tool for the job. So start with sort of high-level tools, maybe speech-to-text API, maybe a pre-built image classification model. And then once you get the feel for how ML is useful, you'll be more motivated to go in and learn TensorFlow and do the nitty-gritty details. But I'm sure Sarah, you have thoughts on this.
Yeah, I think one of the cool things that I've seen recently is there's a lot of tools that are just making machine learning more accessible to people that may not have a technical background. So things like AutoML, which we'll get into probably later on, really help a lot with that.
There's also a tool I adore called Teachable Machines. In fact, I did.
I've seen that one.
On the
It's
Google
awesome.
Cloud channel. Yeah, even it's like a way for you to train a model, like an audio or a vision model. And it's like I had like a 10-year-old kid email me a model that he trained using it. So he's very smart, but it was a very user-friendly tool.
There's also a great resource called Machine Learning Crash Course, which is made available by Google. It used to be just internal training that was used at Google, but we made it public a few years ago. I'm constantly going to the glossary on that site just to remind myself common machine learning terms.
Yeah, that's awesome. I mean, if a 10-year-old can do it, although he is super smart, then I feel like that's motivation for us to get started. And believe it or not, I was always okay at math and stats and I wasn't classically trained in technical skills, I guess you could say. So it's nice to know that, I can do machine learning by using all of these resources that you've just listed online. I think now more than ever, there is a plethora of things that you can find. So,
well, Stephanie, I don't think you should hold other people to your bar because it's pretty high, but I get what you're saying.
Well, thanks. I mean, we all had to start somewhere, right? So, okay, let's go ahead and move on to our next question, who is from Krikzuba, I think is how you say it, who asks, can you clarify what's the difference between Vertex AI and your old AI platform? This is so confusing. Okay, I'm going to admit that I was a bit confused at first too, but it's actually quite clear once explained. So Sarah, we'll go to you for this one.
Yeah, sure. So I've been getting this question a lot since Vertex AI was announced a few weeks ago at Google I/O. So basically how you can think of it is that Vertex AI includes everything from the AI platform that you know, but it also includes AutoML. And the best part is that it includes a lot of new products for ML ops, ML operations. So ML ops is basically the practice of productionizing your models in a way that's scalable and reproducible. So the ML ops products that are part of Vertex AI include pipelines, feature store, model monitoring, maybe some others in there that I'm forgetting. And then one of my favorite parts about Vertex AI is that whether you're training a model with AutoML or you wrote your own custom model code in something like TensorFlow or PyTorch, all of those models show up in the same unified UI, and they can be deployed to the same endpoints. So it's a much more streamlined experience. Would definitely recommend that you use Vertex AI for all of your new machine learning projects on Google Cloud. You can also migrate your old models from AutoML or AI platform to Vertex AI.
Yeah. I mean, I've gotten the question a lot too. And I like to tell people that you can think about it like an evolution of AI platform unified. So that, like you said, you have one experience and interface for both AutoML and creating custom models, but it's all shared infrastructure, data modeling, UX, and API layers so that you can quickly move from data science to production. And it's useful for ML novices, for, with AutoML. But then, as you become more experienced, you're able to manage constraints and make your own fine-grained decisions with Vertex AI. So yeah, this is exciting.
Yeah, you bring up a good point about experience. So it's meant to be able enable you to use ML regardless of your ML expertise. So if you're new to machine learning, there's tools for you on Vertex AI that you can use. If you have more ML expertise and are building your own custom models from scratch, you can use Vertex AI as well. So it works across the board.
And just to riff off what you said, Sarah, I think we've been thinking about how you build and deploy machine learning models for a long time. You need GPUs, you need hardware, blah, blah, blah. But the idea behind Vertex is, well, if you're actually going to use ML in production, there are all sorts of other things you probably would find useful that are not necessarily the ML part, like keeping track of your data sets and how they've changed. And what is your model doing when it's making predictions, keeping a log of how the data distribution is and whether it's drifted. So the idea with Vertex is, yeah, you get the model building, but you get all these other useful things that integrate really nicely in one spot and one API.
Well, speaking of integrations in one spot, this is a perfect segue because our next question is from Chiru B, who asks, why would I use Vertex pipelines when I can use Vertex training and prediction, all parts of Vertex? So Sarah, why don't you actually start by answering that for us?
First, let me start by describing what Vertex Pipelines is. So Vertex Pipelines essentially lets you run end-to-end machine learning workflows on Google Cloud using Google Cloud infrastructure. And you can write your pipelines using popular Python libraries like Kubeflow pipelines or TensorFlow extended. And so a pipeline consists of steps or components. So you break each ML task in your pipeline down into a series of these steps. And so one step might be for importing your data set, one step might be for training, then one step for deploying your model. So that's the purpose of Vertex pipelines. And what you can do is you can actually have a step that would use Vertex training and Vertex prediction. So say you have a model that you're training, you want to have one of your components use the Vertex AI training service to train your model at scale. And then maybe you want to have a step that evaluates your model and looks at a threshold. So maybe you only want to deploy your model if accuracy is above, say, 95%. So you can actually add conditional logic to your pipeline and then say, check my model accuracy, or you can define whatever metric you'd like. See if it's above this threshold. If so, deploy it to Vertex prediction. But you can also use Vertex training and prediction on their own. You don't have to use it in a pipeline. So what I'd probably recommend is, as you're getting started, prototyping, developing your machine learning models and workflows, start by just using training and prediction standalone. And then when you're ready to scale that and you've devised what all the steps you want in your pipeline to be, then convert that into a pipeline and run it on Vertex pipelines. Hopefully that clears things up.
I'd also add, and so sorry, Stephanie, I just also wanted to add to what Sarah said and tell me if you agree that I feel like with software development, there's often, especially for developing for the cloud, there's often this trade-off between how easy something is to get working and how easy it is to port between different running environments. So if you were having a machine learning pipeline running on premises in Kubeflow pipelines, you can move it from your local on-prem environment to Google Cloud more easily. But it's probably more work to set up pipelines than it is to just use Vertex's prediction service. Maybe you get that running really fast, but then maybe that's harder to remove from Google Cloud. So there's sort of this compromise between portability and ease of use.
Yeah, I totally agree with that. Like if I was building something on my own, maybe I would start by using training and prediction, but then let's say I wanted to share it with you, Dale and Stephanie, so that you could run it on your own machine. It's going to start to get a little complicated. I'm going to need to make sure that you're, using similar environments and have dependencies set up. So in that case, I might just want to create a pipeline that each of you could kick off, and then we could track all of the output from that pipeline across different runs.
Yeah, I love the option to have that collaborative approach. And what I love about Vertex pipelines is that it's giving you ML ops, which we've touched on and talked about here, aka applying DevOps strategies to ML systems so that you can build and release code changes, monitor systems and reliability. And like you said, it goes hand in hand with training because you can reuse a pipeline's workflow to train a new model. So I love how it's all integrated into each of these parts. Let's go ahead and move on to the next question, which is from Aravind S., who asks, how do I use image data with natural language processing? And we'll go to Dale for that one.
Interesting question. There are a lot of ways you could answer it depending on how you interpret it. So one would be, is there text in the image? Because that's a matter of maybe using OCR to extract the text, and then you just have a normal natural language processing problem. But maybe you're actually asking about, like, what are some cool machine learning techniques to use images and text together? I love this question because it's something that lots of people are thinking about in the ML space now. Normally, we kind of like weirdly siphon the way we think of ML problems into, here's the set of video problems and image problems and audio problems and text problems. But in reality, if you're trying to take advantage of data that's in the world or on the web, a lot of times what you have is a multimodal data set. You have images with captions is one perfect example. For example, learning how to caption images is one really neat combination of these two modalities. One trend that I see that's exciting today is the ability to find ways to use machine learning to represent data like images and text so that what you learn from text transfers to what you learn from images. For example, if you have a model that looks at text and learns that, usually men are the ones that have mustaches. This is a very contrived example. You learn something about the relationship between facial hair and men, then maybe when you see images, you can transfer what you read about in text to the images and vice versa. So basically, humans learning from audio, text, and images, and maybe machine learning models can now too.
Okay, so the next question is from Pascal L., who asks, how can you use data from Google Cloud Storage or BigQuery to train models on Google Cloud? I love this question, so let's go ahead and go to Sarah for this one.
Thanks, Stephanie. So all of our services across Google Cloud are really well integrated, which makes it easy to import data from other places in Google Cloud when using it for training models in Vertex AI. So when you're creating a new data set in Vertex AI, you have a few options for where you want to import your data. You could either import a file locally from your computer. You could provide a link to a file in Google Cloud Storage. Or you could even provide the URL of a table in BigQuery. So for those of you that don't know, BigQuery is our enterprise data warehouse. So you can connect your BigQuery dataset to your dataset in Vertex AI. No need to download the data and re-upload it. Vertex AI will handle that integration for you. And then one other thing I want to call out is we have a tool called BigQuery Machine Learning. So what this lets you do is it lets you take your structured data in BigQuery and use that to train custom machine learning models. And you don't have to worry about writing that underlying model code. That's all handled for you by BigQuery ML. You just choose the type of model you want to use. And one other thing I'll mention is that related to services being well integrated, if you're using a Vertex AI notebook, our hosted Jupyter Lab notebook solution, and all of your resources are in the same project as that hosted notebook instance, you don't have to worry about authenticating. That's all handled for you within Notebook. So let's say I want to take my data set in BigQuery and download that into a Pandas data frame within my notebook. I can do that easily using the hosted notebook solution.
I think, like, as a lazy machine learning engineer, I and surely many other people like underestimate how much of a big difference this makes when, like, your data is kind of in the same place as your notebooks, and your notebooks are hosted on the cloud and you don't have to be constantly refreshing them. It's really makes you more efficient when it's all in the same spot.
Yeah, there's something to be said
definitely.
about a seamless experience without, context switching and the authentication built in. It's integrated. I think between Google Cloud Storage, BigQuery, and Vertex, you have options, whether it's batch or streaming data, pulling it from Google Cloud Storage, or using the console or API to upload from your computer or cloud storage, and then make modifications and start the training process. So the next question is from LG Good, who asks, is it important to know TensorFlow and PyTorch? So Sarah, can you answer this one?
Yeah, sure. So the short answer I would say is that you don't need to know both. You can choose whichever one is best for the job. There's definitely no harm in learning both if you'd like to, but both have really active communities. So if you need help with issues you're running into, there's a good chance you'll be able to find support. And the good news is that both TensorFlow and PyTorch run on Google Cloud Vertex AI. So if you write models in either one, you can train and deploy those on Vertex AI.
Easy enough. So our next question is from Chibi C, who asks, can I use Google Cloud to train models and generate predictions on text documents? Dale, I have to go to you for this one.
Yeah, actually, we could both talk about this because just the other week, we both talked about Document AI on the GCP podcast. And so Document AI is a tool for everything machine learning in documents, whether something, a picture, a paper document that you take a photo of or a scanned PDF. So it allows you to read the text off of a page. It allows you to understand what text means within the context of a page. Like maybe you have a table or you have a form and you want to understand this is the field birth date and this is the value for within birth date. So yeah, the Document AI tool set. I mean, I don't know, Stephanie, what do you think of that?
Yeah. So once again, we just talked about this on the GCP podcast. And what fascinated me about Document AI was that under the hood, these pre-trained models that are built by Google Cloud are using computer vision, including OCR and natural language processing that creates these high value, high volume documents. And then meanwhile, on the podcast, we also talked about, our knowledge graphs, which validate and enhance the fields in your documents. And you can train and create your own custom document models and still have human interaction with AI to ensure accuracy when you need it. So pretty cool stuff.
Yeah, one of the things that this reminds me of now that you bring up the knowledge graph is I love, I'm a Kindle person. It's okay. I don't need paper books. And one of the things that I love about reading a book on a Kindle is if I don't know a word, I click on it and boom, there's the definition. It's like maybe connected to the web. Maybe I even get a translation all right there in my book. Document AI enables a similar thing where maybe I'm looking at an invoice and there's a business with an address and I click something, and because of the integration between the data on the page and the Google Knowledge Graph, I know, is this an active business and what type of business this is by linking it against web data.
Right. It's like not just text anymore. It's this window into more metadata and information beyond that, which, we can represent through this knowledge graph. So it's pretty amazing stuff. Our next question comes from Mo B, who asks, could you give tips on operationalizing ML models? How would you go about it and based on what? So Dale, how about we go to you?
Yeah, sure. I'm happy to answer this. I think your biggest concern when you have a model in production, well, there are a couple. First of all, you want to make sure that the data that you're making predictions against is the same as the data you trained your model on. This is like one of the biggest places that people have issues. They train their model on some sample data set, and then when they get predictions from the real world, they're out of sync. So when you're operationalizing your model, you want to be able to have a way to check for that, to be able to automatically, over time, as the world changes, check for a drift between your training data and the real world data. And probably also a good way to deal with the fact that the world changes is to have a way of collecting the new data as it comes in and you make predictions against your model, and then automatically retraining your model and updating it with new data. So that's the first thing that comes to my mind. Sarah, I'm sure you have a lot of thoughts on this.
Yeah, I would add to that. So everything you described, you can do that in Vertex AI. You can automate this workflow using Vertex pipelines. And one of the cool MLOps services that's available as part of Vertex AI is called model monitoring. So it lets you do exactly what you described and detect drift. So if the new predictions that you're getting coming in are different from the data that you use to train and evaluate your model, chances are you'll want to find an automated way to get alerted about that. So you can set up alerts so that you'll get notified when a certain threshold is reached based on, if you're looking to identify drift. Then you can kick off model retraining, do whatever you want within a pipeline.
Yeah, and this all kind of speaks to this other topic that we recently had on the podcast, which was responsible AI. And to me, ML ops is this major evolution in ML practices because you can not only reduce the amount of time it takes, but you can reliably go from data ingestion to deploying model in production. And like you said, monitor and understand your ML system it's reliable, it's efficient, and you get that explainability, that transparency, so that you can have these healthier, more representative practices and models. So
yeah, one thing I actually forgot to mention is one of the great things on Vertex AI is feature attributions, which are available for different model types. So for example, if you train a tabular model in Vertex AI using AutoML, you can get feature attributions, which basically show you which features influence your model prediction the most and what's signaling that prediction. So it really lets you, look under the hood and have a better understanding of how your model's performing.
yeah, and you were able to leverage some of this for some of your past projects, like the cooking one, right?
Yeah, definitely. That was a fun one.
Yeah,
Sarah and I, this is Sarah's project originally, but she invented new recipes using machine learning, and then we kind of riffed on it together. And yeah, you want to tell us about it?
Yeah, definitely. And you should all check out the video that Dale and I did on this. Basically what I did is I've been baking a ton during the past year and started to notice that baking recipes in particular follow a lot of distinct patterns. So there's a specific ratio of like flour to fat to sugar that makes a cookie distinct from a cake. So I wanted to see if I could train a machine learning model to start out. I trained a model to predict what different recipes were, starting with just 3 labels: bread, cake, and cookie. And then I wanted to see if I could use this model, tweak the features, the inputs, play around to see if I could invent a new recipe. So the first one I created was this hybrid cake cookie that I called a Cakey. It was pretty delicious. We attempted in the video, and we also make a new one. It was fun.
Yeah, you have to check that out. And I think you also partnered with Mars and did some things with confectionery, and you made some recipes with that too. So you've done a lot in this space.
Yes, big fan of baking and ML.
You may be
if anyone has thoughts on
baking machine learning expert, I think, in the world.
Yeah,
it's such a fun hybrid. Yeah, the Mars project was really cool too. Basically flipped the model that Dale and I described in the video, flipped that. So instead of providing ingredient amounts as input, you provide what you want to make. So I would say, I want a 50% cake, 50% cookie. And it would tell you the amount of certain base ingredients that you need to make that. So there's a blog post on it. We can provide a link.
We might need a spin-off show for you.
I'm up for it.
All right, so our next question is from IDRL Indian Drone Racing, who asks, how can we use less images to train a model? So Dale, can you help us out with this one?
Yeah, I think the question is, how can we use less data to train a model in general? And also, do we even need to train a model? This is what I'm always thinking about, because if you follow it all, the type of projects that I build using machine learning, I'm always trying to avoid collecting data. This is the slowest part of the project. This is the most error-prone part of the project. It prevents you from prototyping quickly. So I'm always wondering, how do you get the most out of models without finding data? So the answer that everybody usually thinks of is something called transfer learning. To understand how transfer learning works, you kind of have to understand that the way that machine learning works in general is not that you're learning from data to understand how to do a task, like identify dog breeds, right? That a machine learning model, when it looks at tons of images, not only is it learning to identify dog breeds, it's also forming some understanding of the world in general. It's understanding that animals have ears and 2 eyes and usually a nose in between. So in addition to trying to learn what your task is, it's also representing the world. This allows you to take a model, an image model, for example, that was trained for something completely unrelated to classifying dog breeds. Maybe it's used to classify all sorts of objects. And then you bring your own data with your own custom task and you tweak and you tune that model to do what you want. So you take the model that understands the world, then you say, okay, but now find a way to do my specific task. So this is transfer learning. It's been used, for a couple of years now. Most image models will build on top of another image model, but we're seeing this even go farther now. For example, there's sort of a trendy topic called one-shot learning, where the idea is I want to get a model to do my own custom task, but I'm only going to provide a couple of examples. I'm not going to provide a whole training data set. I'm going to depend on the model being good enough to be able to generalize. And if you look at models like GPT-3, this is a text model, a really, really good multi-purpose text model. You can get this model that was trained once on one data set to write code, write poetry, do translation, be a chatbot. So we're moving forward towards this trends in machine learning where can you build a large model that's really good, that's so good in fact that you can use it for multiple tasks without finding training data. That is my hope for where we get to answer the question of how do you avoid collecting so much image data.
Yeah, it's really exciting because I feel like it's all about making this more efficient and the upfront work less on the people who are doing it. And if I understand correctly, so transfer learning means reusing a pre-trained model on a new problem that you're trying to solve. So like for image classification or NLP, like this is a starting point for you to help develop a neural network model on image or these types of problems, because typically there's like a lot of compute and time resources required, right?
Yeah, you could kind of think of it as, imagine you need a data scientist to write SQL, but all you have is like a software engineer, right? But there's a lot of skills that transfer between writing SQL and writing Python code. So like it's better to start with a software engineer. They're going to get the basic concepts, and then you can train them with less time to do the other task.
Right. Well, there's a lot happening in the space, so I'm sure it's going to get easier and easier as time goes on. So the next question is from Taha, who asks, is TensorFlow.js the way to go if you want to do real-time computer vision on the browser? I really wish I could do that with OpenCV. So Dale, let's start with you.
Yeah, sure. I guess you're asking me because we've talked about a recent project I'm working on with TensorFlow.js. What I love about TensorFlow.js and also the tools built on top of it is that it's just machine learning part of aside, it just has a lot of nice utilities for collecting sensory data from the browser, whether it's from the camera or for a microphone. It has like library structures to just hook into that stream really quickly. And so it just makes any sort of real-time sensory-based project much easier to build. I don't know, have you guys played with this at all?
I haven't played with TensorFlow.js yet, but I have been meaning to. I'm excited about your new project on it.
Yeah.
We're building a pet cam, so...
I'm excited. And they actually talked about this in I/O pretty extensively when they were covering AI. So seems like it's something that is to be focused on. The next question is from Diego N, who asks, how do I use AI solutions in a small business with a low budget? So Sarah, can you help with this one?
Yeah, definitely. This is a great question. So the first thing I'll mention, and this is available across a lot of different Google Cloud services, not just limited to AI and ML, is to take advantage of auto scaling. So for example, when you're deploying a model, when you're configuring the machine type and the settings, you can set that to auto scale so that you'll only be charged when you're getting prediction requests on your model. And then if it's not active, it'll scale all the way back down to 0. But I will also mention that AutoML, which we've talked about a bit, is pretty cost effective and a great way to start prototyping and developing models that could eventually become your production models. So for example, if you want to train an AutoML tables model, an hour of training, which I find usually gets me pretty good accuracy, costs $20. And for video, text, and vision, it's actually only $3 per hour of training. Just found this out today. Super excited about that. Yeah, pretty awesome. So another thing to think about is like your time is also valuable. So if you're going to be spending time like spinning up a lot of this infrastructure, it might be a better use of your time to just use the cloud, take advantage of managed services to do that.
Yeah, right. I 100% agree with what you just said, Sarah. Like zooming back from the SKUs on specific costs of products and compute time or whatever, like the most expensive thing that you could possibly spend money on is probably buying like a set of PhDs or data scientists, right?
Totally.
So the way you can really save money is, especially when you're starting off, when you're building an app totally from scratch, use the pricier tool if it's like way easier to use. Build out the prototype and then bring in the experts once the proof of concept works.
Right, because chances are you want to focus on your machine learning skills and improving and making sure your data looks good. And using managed services really let you focus on like the core of your machine learning tasks rather than spinning up all that compute.
Yeah, I totally agree. I can't overstate the importance of, getting up and running quickly and then utilizing managed services and moving towards that progression of hiring the right people. And, like we said earlier, Vertex AI is that platform that you can continue to develop and progress as your business gains more resources. So Unfortunately, that's actually all the time that we have for today. So Sarah and Dale, I want to thank you so much for spending time with us. Before we wrap up completely, Dale, do you have anything that you want to leave with the audience?
I just really, really want to know what people are working on. So if you have a machine learning project, please tell me about it. Tell me about it on Twitter. If you disagree with anything I said, pick a fight with me. I want to know what you're thinking. So thanks for having me, Steph.
All right. She said it. She's willing to take a fight with you. So Sarah, how about you?
Yeah, I would echo everything Dale said. And also I want to add, I'm working on building out some ML tutorials, and I'd love to hear what kinds of tutorials you want to see. So please drop a note in the comments and let me know what you're looking for.
Yeah, and I think, we'll try to include some links in the description today and after today, and we're going to be responding to your questions. So thank you everyone for joining this episode of Ask Google Cloud live chat. We hope that your questions got answered, and we are going to be back with more of these live chats throughout the year. We'll be featuring your questions from YouTube, Instagram, Twitter. So send in your questions using the hashtag AskGoogleCloud and comment below if you have a question that we didn't get to today. I want to thank you all for watching, and we'll see you all next time. Bye.